everyone, I'm Wardah, a STEM Scholar Mentor, and today we'll be going over Lesson 4 of Unit 4 of Algebra 1, Rate of Change. So first, let's go over rate of change what rate of change really means. It's a measure of how two variables are related to one another. Rate of change can be expressed in many ways. So the most common way that you'll see rate of change in math is slope. Next is the variable m, which can be found in the slope-intercept form. Then we have a formula, y2 minus y1 over x2 minus x1. You can use this in when it comes to coordinates on a graph for two coordinates, or you can also use them in a table. Next is rise over run, which we're going to use primarily for graphs. And next is change in y over change in x. So that's what the triangles mean. It just means change in y. So I'm going to go over how to find rate of change in both a table and a graph. So in a table, I really like to use y2 minus y1 over x2 minus x1. So you just do 1 minus -3, and then over -1 minus -3. But what they did here is they found the difference, the difference between two coordinates in the y section and then two coordinates in the x section. So they have, first they did the x's, +2, +4, +3, and +1. That's the relationship between these coordinates. And then here, +4, +8, +6, and +2. And then they put the x's over the corresponding y's. So 2 over 4 equals 4 over 8 equals 3 over 6 equals 1 over 2. So we know that these are all equal to one another, and that's how we find out that the rate of change is constant. But I would recommend just using y2 minus y1 over x2 minus x1, because this is kind of confusing to me. But if this really does help you, then you can use this way too. So in a graph, it's a lot less confusing because it's visual. So here's where we're going to use rise over run. So we're given 2 points here. They're marked. The first one is -4, and I believe that's 6. -4, 6, and then here we have 4, 6. So to find the rate of change in these 2 points, we're going to do rise. So rise is going up on the y-axis. So that's 1, 2, 3, 4, 5. So we know that I don't know why I said this was -4, 6. It's -4, 1. But regardless, we're going to do 1, 2, 3, 4, 5. So the rise is 5. And then our run, we're going to run right. So our run is 1, 2, I'm guessing 3, 4, 5, 6, 7, 8. So our rise is 5 and our run is 8. So since it's rise over run, our slope or our rate of change would be 5 over 8. Now I want you guys to do 2 questions on your own. Don't worry, we'll go over them later. But this is the first one, so pause the screen and complete it. And here's the second one. Okay, so these are the answers you should have gotten. Number 1 is 1, and number 2 is 4. So let's go over number 1. Here we have our graph, and they asked us to look at each interval and find which had the biggest rate of change. So here's a little hint. The steepest slope in a graph will always have the biggest rate of change. So even without doing any math, we would know that this interval, hour 0 to hour 1, is the answer. But let's go over it mathematically anyways. So we know that we're solving for this slope here. And our coordinates are 0, 0, and 1, 2. And here's why. So here we have 0 for our x-axis. This is our point. And then 0 also for our y-axis. And then for the second point, which is up here, we have 1 for our x-axis and then 2 for our y-axis. So those are our coordinates. Next, we're going to use y2 minus y1 over x2 minus x1 to find out the slope or the rate of change. So we're just going to plug those in. 2 is y2 minus 0 is y1. So y2 minus y1. And then we're going to correspond with x's. x2 is 1 minus x1 is 0. So our formula is 2 minus 0 over 1 minus 0. When we solve for that, we get 2. 2 minus 0 is 2. 1 minus 0 is 1. And this is equal to 2. So now we know that this interval is equal to 2. We're going to repeat these steps for each interval that they gave us. So 1 for this interval, which we just did. And then the next one would be for hour 1 to hour 2, hour 2 to hour 3, and then hour 3 to hour 4. After doing that, these are the answers you should have gotten for each part. So after seeing this, we know that hour 0 to hour 1 is our greatest rate of change. So that's our answer. For the second question, they ask us to do a lot of work. So let's do it all together. So when I was saying that we were going to use y2 minus y1 over x2 minus x1 in a table, here is how we're going to do it. So we have 5, our coordinates would be 0, 2, and then 1, 5. We're going to plug that into our y2 minus y1 over x2 minus x1 formula. So 5 is y2 minus y1, which is 2. 1 is our x2 minus 0, which is our x1. Then we solve this. 5 minus 2 is 3. 1 minus 0 is 1. So the rate of change for this graph is 3, which we know is not equal to negative 3, so 1 is not our answer. For the second one, we can use the same the same formula. So we're going to start off with our coordinates. We're going to use the first two. So 1, 5, and 2, 2. So y2 is 2. And then our y1 is 5 here. Our x2 is 2, and our x1 is 1. So then when we solve, 2 minus 5 is negative 3. And then 2 minus 1 is 1. This is equal to negative 3. But now we need to check if our rate of change is constant. Now the way we're going to do that is just by using these two coordinates now. So 2, 2 and 3, negative 5. We're going to plug it in. We're going to plug it in into the same formula. So our y2 is negative 5, y1 is 2. Then our x1 is 3. And our x2 is 3, and our x1 is 2. When we solve, we get negative 5 minus 2 is equal to negative 7, and then 3 minus 2 is equal to 1. We know that this is negative 7. It is not equal to negative 3, so 2 is not our answer. For 3, we're going to use, we're just going to use the same formula over and over because that's the quickest way to do this. But first, we're going to find our points. So we're going to use this point here and this point here. When looking on a graph, you always want to use points that are placed on these lines, just to make it a lot easier for yourself. Because if we were to use, say, this point, we would just have to guess what our coordinates were. But we know that this is a solid interval. So for these coordinates, they're written as this because this is 0, 3, 1, 2, 3, 0 on the x-axis, and then 3 on the y-axis. Then we have 1, 1, 1 on both the x-axis and the y-axis. We're going to plug it into our y2 minus y1 over x2 minus x1 formula. Y2 is 1, y1 is 3, x1 is 1, x2 is 1, x1 is 0. When solving, we get negative 2 over 1. We know that this is equal to negative 2. This is not, and negative 2 is not equal to negative 3. So this is not our answer. Now we're left with 4, so that must be our answer. But we're going to solve for it anyways. So this is in slope-intercept form, which is y equals mx plus b. And as we said before, the variable m is also equal to rate of change. So this is our slope here. But we can simplify this further. So we're going to divide this entire thing by 2 to get y equal to 1. We always want our y to equal to 1 so that we know the correct slope or the correct rate of change. So after dividing this entire thing by 2, we get y equals negative 3x plus 5. So we know that m is equal to negative 3 when we correspond it to the formula, and which means that our slope is negative 3. So 4 is our answer. That's it for this lesson. Thank you for listening. And if you have any questions, don't be afraid to reach out on my email below. I know this was kind of an absorbing lesson. And if you want to practice with any additional resources, JMAP and Khan Academy are some great ones.